Imagine you are lying on a quiet beach at night. Waves slide up the sand with a soft hush, then fall back. Overhead, the sky is wide and dark, scattered with calm pinpoints of light. These stars look small, yet each one is a blazing sun hanging far away in the deep sea of space. You can see the gentle shimmer of starlight, and you can feel the cool air on your skin. In this quiet moment, you might think you are seeing most of what is out there. But the truth is, almost everything in the universe is hidden. The peaceful night sky hides a mystery that fills more space than all the glowing stars you can see. This hidden part of the universe is called dark matter. When we say dark, we do not mean a color you can paint or a shade you can pick on a screen. Dark in this case means invisible. Dark matter does not shine, does not glow, does not give off warmth. No telescope can catch its light because it makes none. Think of it as a gentle, silent ghost sea that soaks through every galaxy. Even though we cannot see it, we can tell it is there, the way we can feel wind on our face while our eyes stay shut. Wind is unseen, but its touch is clear. Dark matter is unseen, but its pull on stars and on us is clear. The best path into the story of dark matter begins with motion. Picture a merry-go-round in a playground. When children hop on and push, the plates of wood spin faster. If too many children jump on the edge, the ride flies apart. Now picture a galaxy, which is a spinning disk of dust, gas, and many stars. Planets twirl around stars, and stars twirl around the center of the galaxy. Long ago, astronomers expected that stars near the edge of the disk would move slower than stars near the center, just like seats near the hub of a wheel move slower than seats near the rim. But when they measured the speed of outer stars, something seemed off. The edge stars were moving much too fast. At those speeds, the outer stars should have been flung off into the dark of space. Yet they stayed in place, calmly circling the center decade after decade. It was as if an unseen hand was holding the stars in a loose, steady grip. That unseen hand had mass, weight, because only mass can pull with gravity. But where was that mass hiding? No glow, no clouds, no hot gas showed up in their telescopes. The only answer was that something invisible must be filling the galaxy, adding extra pull to keep those fast stars from flying away. That something was the first hint of dark matter. Years later, many other galaxies showed the same strange behavior. All of them spun faster than the visible matter alone could allow. And so the idea of dark matter became harder and harder to ignore. Astronomers drew maps of clusters of galaxies, huge families of hundreds of galaxies drifting together. They saw that these clusters, too, stayed clumped when they should have scattered. Again, the only answer that fit was extra hidden mass, acting like glue. To confirm, they used a clever trick called gravitational lensing. Gravity bends light, much like a glass lens bends light. When light from a faraway galaxy passes through a cluster on its way to us, the cluster's gravity bends the path. By measuring how much the light bends, astronomers can weigh the cluster, even the invisible parts. They found far more weight than the bright parts suggested. The excess weight proved once again that something unseen was piling into those clusters. Today, when we add up all the matter that shines, glows, or gives off any energy we can catch, every star, planet, cloud, and dust grain, we get only about 1/6 of all matter. The other 5/6 is dark matter. You can think of dark matter as the invisible frame of the universe. Galaxies sit inside halos of it, like sparkling snow globes inside glass domes. Without those halos, galaxies would never have formed. In the young universe, gas would not have had enough gravity to gather itself into the first stars. Dark matter supplied that gravity, clumping first, then pulling gas into its grip, then lighting the first cosmic candles. Every bright point you see tonight, every sunset you have watched, owes its birth to dark matter's quiet help. Now, what could dark matter be made of? It cannot be made of ordinary atoms because atoms interact with light and would not stay silent. Most scientists think dark matter is made of brand new, still unknown particles. Think of particles as tiny bricks of nature. The atoms in your body are built from protons, neutrons, and electrons. Dark matter may be built from another family of bricks that do not care about light. These bricks pass through walls of atoms like a breeze through a broken fence. Because they slip by unseen, we have not met them yet, but we are setting traps. Deep underground, labs hold tanks full of noble gases, cooled until they are still and clear. Sensors listen in the dark, waiting for any tiny nudge that might come from a dark matter particle bumping into a normal atom. On mountaintops, telescopes track flashes in the sky that might show pairs of dark matter particles smashing and turning into bursts of light. In huge machines called particle colliders, scientists smash protons together at near light speed, hoping that some of the energy pops out as dark matter particles, which would slip away, leaving a tiny trace of missing energy. So far, these traps have not caught a clear sign, but patience is part of the adventure. To find something that never glows, you must be both clever and calm. Some researchers suggest dark matter might be even stranger, perhaps black holes as small as mountains, left over from the wild first moments after the Big Bang. Others wonder if gravity itself may act differently on large scales, wiping out the need for dark matter. But most evidence still favors the idea of invisible particles. Each new observation of galaxies, clusters, and the early universe tightens the net around those particles. Like fishermen drawing in a long line, we keep pulling, listening for a tug that signals a catch. Meanwhile, dark matter stays busy shaping the cosmos. When two galaxies pass through each other, their stars seldom collide because space is huge. Yet the dark matter halos overlap and mix, steering the dance. Large halos merge to make even larger ones, and the galaxies inside light up in fresh waves of starbirth. In big sky surveys, astronomers slice the universe into three-dimensional maps that show giant webs of matter. The bright galaxies lie along the threads of this web, and the spaces between are vast dark matter gaps. Experiments with computers, called simulations, start with dark matter alone and watch how it clumps under gravity. Gas and stars are added later. The bright parts fall exactly where we see galaxies today. The match is so good that it is hard to imagine dark matter is not real. Still, many open questions float in the night. Does dark matter ever talk to itself, bumping and scattering with other dark matter particles? Or does it pass through them too? Does dark matter form tiny, dense cores, or does it spread in puffy clouds? Could our own Milky Way hold a hidden dark matter disk, spinning under the bright disk we see? Could streams of dark matter flow through the solar system even now, like rivers under clear water? Each question is a doorway to new research, new machines, new ideas, all gently humming in labs while most of the world sleeps. Even closer to home, dark matter slips through your body every second. Billions of particles may be zipping through you right now. They pass without a sound, skimming through atoms the way rain passes through a chain-link fence. You do not feel them, and they leave no mark. Yet without their distant cousins holding galaxies together, we would not be here. For something so quiet, dark matter has a loud role in our story. Imagine again the night sky above the beach, but shift your gaze to the black spaces between stars. Those spaces look empty, yet they hide most of what is out there. Think of dark matter as a grand, soft quilt spread across the cosmos, cradling the bright stars like tiny glass beads sewn onto fabric. The quilt keeps them from drifting apart and losing their shape. It drapes every galaxy, wraps every cluster, and joins them into filaments that stretch for hundreds of millions of light years. Because the quilt is unseen, we needed many years to notice its gentle hug. To sense dark matter on your own, try this thought exercise. Picture a tall tower built of blocks. If you remove too many hidden blocks in the middle, the tower would fall. Now picture a galaxy as a tower of spinning stars, and dark matter as the many hidden blocks holding it steady. Take away those blocks, and the outer stars spin off into the dark. If you ever see a photo of a galaxy with graceful arms wrapping around itself, you are really seeing the handiwork of dark matter. Sometimes artists paint the Milky Way as a bright disk sitting in a vast, translucent bubble. That bubble stands for the dark matter halo. The halo is big, 10 times wider than the disk of the Milky Way itself. If dark matter were visible, our night sky would glow with a faint, round haze stretching far beyond the familiar band of the Milky Way. We would live inside a soft, glowing sphere. But nature chose a different rule, and the halo stays silent, leaving the stars to shine alone in the black. When scientists measure the entire budget of the cosmos, they find another surprise. Not only is most matter dark, but most of everything is something else called dark energy, which pushes the universe to expand faster and faster. Between dark matter and dark energy, the cosmos is mostly hidden stuff, with the word dark in its name. Yet dark here does not mean scary. It simply means unknown. The night ocean of space may be deep, but every generation lights another lantern and sees a little farther. Dark matter is one of the next lanterns we hope to ignite. Listening to this story while you rest, you might wonder why we chase something we cannot see. The answer is simple. Every mystery solved adds to the quiet music of understanding. Knowing how the universe holds itself together is like hearing the bass line in a song you love. It enriches the tune. Dark matter is the hidden rhythm of galaxies. Finding its beat will make the cosmic song clearer. And even if we never feel dark matter in our hands, the chase teaches us patience, sparks new tools, and brings people together under one sky. Let your thoughts drift now to the calm space between heartbeats. Just as your body rests, the universe glides onward, held in place by forces both seen and unseen. Stars burn, planets whirl, comets skim along vast curves, drawn partly by ordinary matter and partly by dark matter. Somewhere far away, a young astronomer may be finishing a late shift, checking data points glowing on a monitor. Maybe she has just spotted a small, telling twist in the motion of a distant star. Maybe that twist is the first whisper of a dark matter particle rushing past. She will yawn, rub her eyes, and mark the finding for dawn review. In that moment, the quiet hope for an answer grows a little stronger. Dark matter teaches us that nature does not reveal all her secrets at once. She keeps some surprises sealed behind laws we only half understand. And that is all right. Life, like a night ocean, is richer for the unknown depths. As your breathing slows, let the idea of unseen support lull you. The chair or bed beneath you is firm, though you do not see its wooden molecules. The earth beneath the chair is solid, though you do not see its iron core. In the same way, dark matter is there, upholding spirals of stars, shaping clouds of gas, writing the hidden script of the cosmos across billions of years. Floating in that thought, you can picture the universe as a vast theater. Galaxies are the actors under bright spotlights. Dark matter is the stage crew, all in black, moving sets, lifting beams, guiding every scene from the shadows. The audience, us, rarely sees the crew, yet without them, no scene would stay intact. The play would fall apart. Now, as you drift, know that you too glide on a stage set by forces you cannot see. And that is a comforting truth. not a fearful one. The hidden crew is sturdy and calm. Some night soon, step outside if you can. Look up and pick one faint star. Think of the star's silent partner, the dark matter ball that surrounds it and holds it gently in orbit around the galaxy center. Remember that not seeing it does not weaken its hold. In the hush of night, the most important forces are often the quietest. Such is the nature of dark matter, forever present, forever silent, cradling the cosmos in its unseen hands.